Hello, everyone. Welcome to another session of Real Estate in Action, where we investigate various use cases of AI in practice, but also sprinkled with a little bit of research on how AI is best used across the building lifecycle. So today we have another session, and it's all about how various types of AI are used in building operations. My name is Monica Dinu. I'm VP Marketing at Alasco, and I will be your host today. Before we dive in, just a little bit of housekeeping. This session will be recorded and we will send it back to you after the session is over, together with all the decks and presentations of our esteemed guests, so you don't have to worry about taking notes. And also, if something sparks your interest, please drop your questions in the Q&A channel. We'll do our best to address them towards the end of the session. So, let's get started. This session is for you if you are a property or project developer, if you are an investment manager or building owner, or if you are an asset or property manager. So why did we start these sessions? Because we're hearing about AI everywhere, but we realize there's still a lot of misconceptions on how to apply it, how to select the best use cases, how to drive change across your organization beyond the level of I'm a user and I'm having some prompts and I use it in my day-to-day job. So if you're responsible for development, portfolios, or operations, this session is for you to help you figure out what is actually working on the market today. We had a couple of previous sessions that demystified AI and helped you understand its strategic value. Then another session centered around construction and real estate development flows, and a session on operations. This one goes a little bit further. It's operations part number 2. And then we have 2 more sessions in our series. Again, another episode focused on construction and development flows. And finally, one centered on maybe a very little talked about topic, preparing your organization for AI implementation, namely change management. Because let's not forget, this is a very important part of making your AI projects successful. Also, a quick word on Alasco. Probably know us by now. We're a financial management solution for new developments and retrofits. We have, over the years, over 5,000 projects in basically all the European countries and UK and Ireland, of course. And we work with large, but also smaller project developers, investment managers, property managers, and so on. And we're your hosts today. Okay, and now it's my pleasure to introduce you to our esteemed guests. Henrik Ziegeldorf from Edifion. You probably met Edifion in one of our previous sessions, but today he's here to showcase a different part of AI, because LLMs are very popular, but let's not forget there are certain use cases when machine learning or computer vision make much more sense. We have Dr. Nino Paulus from AlphaPrompt. AlphaPrompt is a company that applies generative AI models to analyze, structure, and digitize large data sets. And particularly, you're focusing on a very important stage of the building lifecycle, namely transaction and due diligence projects. And then we have Louise Mahoney from Ask Porter. Ask Porter is an AI-powered property management platform that acts like a digital coworker for your housing, build-to-rent, and facility management workflows. So, and obviously there's me trying to facilitate the conversation today. So, let's get us started with an icebreaker question. From your opinion, and please, all the participants, drop your opinions in the chat as well. What are the key success factors for deploying AI in your organization? Just to give you some hints, we've heard our customers and prospects telling us that it may be that they're lacking computing power for AI models. They may not have a readily available AI model, and the biggest elephant in the room, the data. So over to you. Who would like to kick it off?
Yeah, thank you, Monica. Good morning, everyone. I'll gladly take the speaking stick. So for us, it's been very clear. There's been a single lesson learned from all of this, and that is that high quality, high volume data set really makes AI work for us. It will be also part of my presentation later, so spoiler alert, I guess. But for us, it's really about the data. So we use the same models as everybody else. We use a compute power that's readily available on the cloud. So that's just a matter of dropping in some money. And so in the end, the differentiating factor for us is the data sets.
Yeah, I would certainly agree with that, Henrik. Hi, everyone. The compute power and also the models, they're really more kind of utility and commodities at this point. And really especially the front end data structure, so the upfront data capture, it really sets the tone on how successful AI can be downstream. So it's really about data fidelity, and spoiler alert, I'll also be touching on that in my case study with Visag, my speaking slot later.
Yeah, what should I add to this? Basically, I can add nothing. I think the high quality data at the beginning of the process of the property is the baseline for everything that follows, whether that's machine learning, that's generative AI, or that's pure process automation as we know it. If you don't have the right data, there will always be a bottleneck.
Thank you, everyone, for your input. It seems like there's an agreement here. How do you, and maybe this is where I hand it over to you, Henrik, because you have a lot of experience in this field. Obviously, data is important, but maybe you touch in your presentation. How do you work with your partners in helping them identify and structure the data and kind of coming up with solutions where data is not readily available? I guess this is the challenge most of us are facing today.
Sure, yeah, that's exactly the challenge everyone's facing. How do you get the data? How do you work with the data? And how do you integrate with solutions that can add value to your data or extract value from your data? And I think we are one of those solutions, and I would be glad to show you how.
Okay, please take over the screen sharing.
All right, I will. So sharing my screens. You should see the cover slide now. Alasco Masterclass AI meets Edifion. So welcome, everybody. And again, I'm Henrik. I'm CTO and co-founder at Edifion. I have a PhD in computer science, so I'm really not from the real estate domain at all. I kind of entered sideways into this venture. And yeah, I'm quite proud today to be here. And let's kick off with the two basic hypotheses that drives Edifion. The first one is that 80% of the buildings that will exist in 2050 already exist today. Edifion starts from the maybe a bit provocative second hypothesis that 99% of these buildings are operated inefficiently. And when I talk about inefficiency, It can be about energy consumption, but it can also be about indoor climate, because your building is also inefficient if it delivers bad indoor climate to your workforce, because they will become unproductive if the air quality is bad, if temperatures are outside comfortable levels. So how do we improve on this? That's exactly the mission of Edifion. We are spin RWTH Aachen University, grounded in over 15 years of research in energy efficiency in buildings and improvement of indoor climate in buildings. We are now over 100 employees, and we believe that energy efficiency in buildings is key to the successful energy transition. So we are on the very ambitious mission to optimize 1 million buildings. And we are at just about 500 buildings today. So there's still a bit of a way to go, but we are confident that we arrive there someday. And yeah, of course, to do this, what you need is automation, and a key ingredient in automation today is AI. So let me show you the basic cycle of what we do. So we connect to your building automation system. We extract data from it. Sometimes we also retrofit hardware to get data from your building. We analyze and interpret your data. For example, we find errors, find optimization potential, and hand it back to you in actionable recommendations, what you can improve about your buildings, or we take over control over your building and actively optimize it for you. And AI is really a key ingredient in every part of this high-level cycle of optimizing your building operation. And let me just share a bit where we put AI in our products and what kind of AI we put there. Because at least for us, it's not all about generative AI and big language models and all of that. We just started from just a lot of more basic stuff. Actually, back in 2017, there was no big language models, at least not the ones that we know of today. So AI in the different products. So first of all, it might seem simple, but we do get a lot of data from buildings. So a typical large office building might have anything from 1,000 to 100,000 data points. We even had an office building in Chicago that had 300,000 data points. So that is a lot of data that we discover automatically and that we need to make sense of. Yeah. So what we do with AI here is we structure the data, we harmonize it, we augment data streams. So for example, we have a classifier that is a classical supervised, classical machine learning trained supervised learning classifier that takes a data stream without a unit, because we might not get it from your building automation system, and it attaches a unit. It tells us, is it a flow temperature? Is it an outside temperature, an indoor step temperature? And it can see that just from the raw data. Another important part here in data processing is mapping the digital twin. So for us, that is a process of getting all your thousands of data points and extracting what kind of devices and components do you have in your building. Do you have a heat pump? Do you have a gas boiler? Do you have an air handling unit? And which data points belong to which device? So from that, we construct a digital twin. And that is also done using unsupervised and supervised learning methods. Of course, we now experiment a lot with adding LLMs in there, because there's also a lot of textual data that we can process to extract that digital twin. For example, we can look at technical documentation from the construction phase of the building to make sense of all the data that we get in. Then we do a continuous analysis of your building operation. So part of that is advanced failure detection and diagnosis. We identify optimization potential, and we generate recommendations and support you in putting them into action. This is mostly classical rule-based expert systems. So we compute different KPIs about your building operation, and if those KPIs fall in the one or the other category, we might issue different recommendations for actions. Of course, that is also a domain where today we experiment with applying large language models. So the rule-based system you could view as a discrete set of recommendations and categories. And of course, if you apply LLM, you can personalize it much more. You can adapt it much more to the actual context and the actual operation of the building. But the core remains here a rule-based expert system, which sometimes is forgotten that this also belongs into the just general domain of artificial intelligence. And then we might take over dynamic control of your building, so to deliver better indoor climate, to reduce energy cost, or to implement demand response use cases in case you have flexible energy tariffs, or in case you have a limit on the maximum power that you might draw from the grid. This is mostly model predictive control, where you have a model, an abstract model of what you want to control. You have live data about it. You feed the data into the model and parameterize it so that you get a parameterized instance of that model, and you can use that model inside an optimizer to make decisions about how the model is going to behave in the future, and then can adjust the operation, the control of your building equipment according to this. So the basic AI setting here is, as I said, model predictive control, but we also use reinforcement learning in here, which is also a classical machine learning technique. And then finally, probably as many others as well, we have added a chatbot assistant to our platform that makes it just a lot easier to interact with our platform, to do efficient troubleshooting, to actually tell it to what to operate and how to operate it, but also to receive personalized explanations. Yeah. So as I mentioned, you get the analysis results in the previous step, and you might say, "Oh, please explain that again to me. I didn't understand that." Yeah. Or please put that in context of what happened last year. And this is something that a chatbot, LLM-based chatbot, can do very, very well. And of course, this uses generative AI that, is the thing nowadays, and that probably also brought us here today. What we also do is that we provide MCP. As I said, we consider data the most important part about all of this. And one key thing that we deliver is the data about your building operation. So we implement AI use cases on our side, on our platform, but we also acknowledge that you might have your own use cases that you cannot implement on our platform, but where you need the data that we collect from your building. And MCP, so Model Context Provider, is a standard way how to provide data to AI models that are not on your platform, but on someone else's. So basically what this means is if you run a Microsoft 365 Copilot on your side, or a Langdog or a ChatGPT, you can integrate with the Edifion platform and your assistant, your AI use case, and can then actually use the data that is on our platform. So let me give you a bit more quick insight into two of these use cases that we did. So the one is Edifion Dynamics. So on top, you see how Edifion Controls actually works. It takes the weather forecast and the measurement data from your building. It feeds it into the trained AI models and uses that data to parameterize those models and to fit the abstract models to your building, to your heat pump and the context of your heat pump, for example, in your building. And this then generates new control signals that are sent back into the building and put onto the building automation, and will then steer your heating system, your ventilation system, and so forth. And below, more or less the same approach, just using different data and different optimization criteria as Edifion Dynamics, which is a product for demand response. So for this, we consider electricity market and PV as inputs, so electricity prices in the most basic case. We again feed it into a model predictive control, and then the optimization criteria is an optimized use of your electrical systems, mostly heat pumps, but can also be other electricity-based systems in your building, like ventilation, but also humidification of air, for example, is usually electricity-based. And then the optimization criteria becomes not the total the total use of energy, but the total cost of energy used. So use energy when it's cheap, when it's green, and avoid to use electrical energy when it's expensive and fossil based. Now for the second use case that I wanted to present, our AI assistant, how does it work? Probably nowadays all of you will have a basic understanding of this. So there's the users that put in a prompt. In the simplest case, this is just a plain question. So here a technician might ask, how do I adjust the delivery head of the pump? Might ask that through a mobile interface, or you have an asset manager that wants the summary of the greatest potential savings for the building so that they can optimize the overall quality of operation of their building. And you can now ask that to the assistant, and the assistant will draw on the data that is in our platform. That can be public data like manuals for the equipment that you have, can be our documentation, can be policy and regulation. So you might also ask, what do I need to do in my building to satisfy the new GEG, the Gebäudeenergiegesetz? It will also draw on private data just for your building. That is the data that we collect from your building automation system and all the metadata around it. And it can also draw on anonymized cross-customer knowledge base. So we might do things in the background like comparing heat pump operations and tell you that you're above or below average with the efficiency of your heat pump, and get that through some kind of cross-learning across our customer base if a customer or a building opts in to participate in that. And then the LLM, of course, generates an answer. So all of this is called retrieval augmented generation. You have an LLM in the middle, which is kind of the brain. So for me, the mental model is always, this is the part that understands natural language. It can draw on a lot of data, search through databases, get the pieces that it needs to generate the answers, and then you as a user get a nice answer from this. So coming back to the icebreaker question at the beginning, there's a couple of lessons learned from this. And I'm going to take a big step back now. And we ask ourselves, so why is AI so successful today? Why has there been this major breakthrough? And there's three key pieces to this. So there's algorithmic advances. So we have new architectures for neural networks. We have new machine learning algorithms, and they basically allowed us to learn faster and better from data, and they enabled new applications. So generative AI, for one, enabled just a whole new set of applications. Before that, we had classification mostly, like is it class 1, 2, 3 to 10, and now we have generative output. So that is algorithmic advances can enable new applications and can just make everything much more efficient. And we asked ourselves, are we going to make a difference here? And we said, okay, we are all pretty smart and pretty motivated, but probably the top AI talent at OpenAI or Google or Microsoft will have an edge on us. And in terms of algorithms, we said, okay, we are just going to use what the researchers and the big AI labs put out there, and we are not trying to be to make a difference here. So the second big thing that made AI so successful in the past is the availability of computational resources. So as you can see nowadays, everybody's racing to build just bigger and bigger data centers. So computational power certainly is a key ingredient in the success of AI. But then again, for us as Edifion, we're just putting a coin into AWS or GCP. We're just buying these resources. We're not building them ourselves. We are not inventing new CPU architectures or GPU architectures or inference algorithms that use SSD, and now we have high SSD prices and all of that. So for us, that's also not a success factor. But the third part, the bigger and better and more data sets, that's where we can actually make a difference. And we did so unconsciously from the start, because when we set out as Edifion, we just wanted the data from the building to deliver our analysis and our control, and we just wouldn't get the data from the incumbents. So what we did is we implemented data access ourselves, and when we said, okay, let's do it very efficient. And nowadays we are collecting data in a much bigger volume and higher granularity and fidelity than the others, and that has left us with a lot of high quality data sets about building operation. And we see that this is starting to make a difference for us. So for us, the single lesson learned in the AI space here is that data sets are the most attainable AI success factors for most businesses, like smaller businesses or medium-sized businesses. That's where you can really make a difference. It's about the data that you have in your operation and that your business generates. Yeah, this is actually not a new lesson, but it has been learned a lot of times in the past. So for example, Peter Norvig, one of the AI godfathers, said, more data beats clever algorithms, but better data beats more data. So it is about the quality and the volume of data. And a similar note is simple models and a lot of data trump more elaborate models based on less data. So this just underlines that it is about the data that you have about your use case and about your business. Now, how does Edifion help you with getting these data sets? So volume. It is really that current AI approaches thrive on large amounts of data. That is also why OpenAI, Anthropic, and all of them, they are around and just buying data sets. They are buying companies because of the data that they own. Yeah? So this is all about the volume and the quality of the data. So what does Edifion do? Edifion collects data about your asset now, whenever, meaning like 24/7, consistently, wherever your asset is and whatever we can reach on your asset in terms of building automation and operational data. Then it's about the velocity. So data today is mostly generated in real time and should also be processed in real time. And when you talk about building operation, this is also true. So you cannot start optimizing it today and deliver a result in 1 month that is then already old. So it needs to be processed as it is generated. And Edifion allows that by establishing connectivity, live connectivity to your asset and to the building automation in your asset. We put the data in the cloud where it's always accessible to you, and we provide stream and batch processing capabilities for that data. And then finally, it's about the variety of the data. So we've also seen that more differentiated data sets avoid biases and lead to better results. So it is about richer, more complex data sets that allow better models and better learning from the data. And yeah, Edifion helps here by emphasizing APIs, by emphasizing data portability so that you can combine your data sets, that you can integrate with our platform. So I mentioned MCP, you can access the data on our platform for your AI as well. And then finally, I would like to invite you to take a look at our case studies. So there's two that, there's a lot of case studies there, but there are two that especially apply to what I told today. The first one is the Katharinenkai, which is a case study together with the Momeni group. This is where we applied dynamics on a real building and used the building as a thermal and electric battery. And the second one is the ship in Cologne, where we save over 500 megawatt hours of electricity per year, or energy per year, sorry, which translates to roughly €5 per square meter per year, which is a very good result here. They are all available online, so please take a look. And I'll be here for the rest of the session today. I'm glad to answer any questions about our application of AI. Thank you.
Thank you, Henrik. I think the use cases you presented are pretty fascinating, especially the Edifion Dynamics, because what you are seeing now, a large part of real estate is moving towards operational real estate. And how can we decrease operating costs, therefore improving the NOI? So I think your solution kind of directly goes to that.
It does, yes.
Yeah, so this is kind of the biggest advantage that I'm seeing, not being so close to your business. Okay, but then maybe let's step back. So you presented us some use cases while you own the building and how to make the most of it in terms of energy savings, costs, CO2 emissions, and the overall well-being of the tenants at the end of the day. Let's see how buildings get acquired in the first place. And with that, I'm handing over to you, Nino. I know you have developed some very interesting use cases in the due diligence part of the process. So maybe you tell us a little bit about that.
Yes. 1 second, and I'll share my screen. So here we are. Yeah. Hi, everyone. I'm Nino. I'm a co-founder of AlphaPrompt. I got a background in real estate, actually, but I also did a PhD, similar to Henrik, a more technical one. My focus was on natural language processing, so which you can consider as the backbone of large language models. So we know how those models work. And at AlphaPrompt, I'm exactly in this position, like trying to understand our customers' needs and issues and translating that into technical solutions. And for today, I decided that before we talk about real estate, I want you to take you on a journey and maybe step back and see how AI is already applied in other industries and what we might be able to learn from that. And the example I'm bringing is also closely related to my daily job. It's basically the world of IT. And I've brought a few slides on that. So how does a developer, software developer, look on a website? Basically, it's just a folder structure with a lot of different files. And so you have the folder where you'll define colors, where you define testimonials on a website, where you have all the images. And everything is pretty well structured in this folder. Or in this directory. And the good thing about code compared to what we have maybe in real estate is that those files and code is quite well connected. So files reference each other, say, okay, if we are, for example, here in client quotes, and we need a customer photo, please go to the images directory and look at customer photos. There you'll find it. And then if you create a blog post, you know, okay, I have to include a client quote back to testimonials. So everything is connected, very well structured, and you can easily navigate through this back end of a website. This is basically how it looks like. And now with agentic AI, we're having, and I want to focus on the explanation of what is an agent and how does it really help. So we're having this agent which basically sits on top of this directory. So he knows all the folders in there, he knows the files, and he's able to search files, to read them, to edit them, or even to create new ones or delete files if he thinks it's not needed anymore. And so now you could approach this agent and say, okay, please, dear agent, create me a new blog page on our website. And then he would first search maybe all the folders and sees, okay, we're having like one folder where there is content. And the next step is he asks for, okay, which files are in this directory, and he sees, okay, there is a blog post. And then again, he knows about all the references and can go through. So he's basically able to create this new page by looking at the existing structure. And this actually does work, meanwhile, so good that if we would want now, we could go to pages or providers like Lovable.com, or even Google has published a new model which is designed for that, so that we could say, okay, let's build a website for real estate AI in action, Operation Part 2. We might give it some context, a screenshot of all the speakers. And this tool would start to build the entire website from scratch, just because it knows how websites are in general structured. And then we could start chatting and interacting with this page and say, okay, hey, we need a different color scheme. And then the agent might look, okay, colors, I have to look here. Then we have the brand palette. I might have to make changes here. And that's it basically. And I can just invite everyone to who hasn't done it yet, go to Lovable, give it some context about your company and say, okay, build a website for it. I'd say within 2 or 3 minutes, you will have the first draft of a website. And then on the top right, there's a button which says deploy or publish, and the website goes live. You get a link, you can share it, and it's really a working website. And that's where we are in IT. So now, critics might come and say, "Pooh, Nino, it's nice, but a website is not a complete application. It's basically the most simplest thing you could do." But the progress here is extremely fast, and I also want to share insights on the development of AlphaPrompt. We are using that as well for our development. And over the last year, those tools got so much better that now I can say what 2 developers were doing at the beginning of last year, they are doing now the job of 5 people with agentic AI. And the cool thing here is that, or just jumping back, the complexity here is while a website might have, a simple website might have 50 to 100 files, roughly, just that you have a number in mind. Like our AlphaPrompt application has several thousands, probably even 10,000 of files and folders. So it's really, really complex. Whenever I go to our backend, I have to search for hours to find where is this one particular functionality, how does it look like, how is it related to other functionalities. So that's really complex. But those tools which are sitting directly in our code base, those agents, they are so good in understanding the references, how everything is related, and then come up with, okay, if you want to change the colors, or if you want to create a new blog post, go there, and there, then you might change it. And they are even so smart meanwhile, and it's, I think, the biggest progress. Just like you can also compare websites to buildings, they grow over time. So this structure sometimes might be corrupted. Someone does something in a place where it shouldn't be, but yeah, that's how it is. They are meanwhile so good that they also detect those minor deviations and say, okay, for all your pages, you have defined the color schema top left, and there is this one single page where the color schema is defined bottom right, which you as a person definitely wouldn't see, but the AI agent, due to its capabilities, is able to do that. So this was one very nice learning for us. So we are developing much faster meanwhile. But we were asking ourselves, okay, it's pretty nice, and IT usually is always, when it comes to technology by definition, like the area where we progress the fastest, or where we see new things first. So the question is, how can we bring this to real estate? In real estate, we don't have this nice folder structure. Every property is different. We're having different asset classes, different building years, just as Henrik mentioned. So some might be quite old, 5 times renovated. The overall structure might have changed. So this is basically what we find in our daily life and operations. Doesn't matter whether it's the ongoing maintenance of a property or management, or whether it's in transaction. But what is still true, even so we're having this big mess in here, there are a lot of connections between information points. Don't even referring documents. Documents are just a way how we store information. In real estate, they might be not as direct, those connections, as they are in code, where it says, okay, go to this file, and in line 500 you will find the function you're searching. So it's not that clear often how things are related, but the relations are definitely there. And so we were asking ourselves, can we get to a state where we basically have this clear structure and it's not just about structuring documents, but more important, it's about structuring the content, the data which is in those documents, and making it accessible, and drawing, being able to draw those lines. How many tenants does the property have? Which tenant sits in which unit of the property? What technical devices belong to which unit, and so on. There are all those lines, and we have to somehow visualize it. And then if we are able to do that, our agents certainly or immediately get more powerful. And that's exactly what we are doing with AlphaPrompt. And now I'm coming to our typical use case. So as Monica said, we are often part of early stages of transactions, but not only on the buy side, also on the sell side. So whenever you're preparing to get your property transaction ready, or if you have an offer on the table and you want to go into due diligence. So what we basically do, to give you an insight, is three things. You just will throw this unstructured mess towards AlphaPrompt, just upload it. And then we have three phases. The first one is what we call our intelligent structuring. That's basically, of course, document management, but more data management. So we will identify, which tenants are there in the property, which communication, which leases, addendums, prolongations belong to which tenant, completely automatically, and then create a rent roll for you at the most granular level. So you could do whatever you want afterwards. If you're going into property management, you'll just export this data to import it into your property management tool. If you're in the transaction process, you will export the rent roll to plug it into your DCF model, and so on. So we're doing this for everything. And since we know the connections between things, it's not just like extracting a lease, but ignoring what has changed over time. No, we know, okay, like for 2 years ago, the rent has been increased. Now the contract has been prolongated. So this is the baseline, this whole data structure connected. And the second step is then to verify this data. So is it really true what we extracted? Are there some anomalies which stick out? So we can also cross-check things. So if you have a rent roll uploaded, which you get from the seller, and you have all the contracts, AlphaPrompt might check for you, okay, does the rent which is given to you in the rent roll really make sense, or is there anything which might say, okay, that's probably not the truth? So we automatically check that for you. We can highlight that to you, so that you get, and then we're coming already to the third point, that you get a verified report, a first due diligence report saying, okay, those are the red flags in the property. You might have to look at those issues. Here's why we think this issue exists, and also what we suggest we could do against this issue, and what's the impact on the value of the property. So this is all done by AI. So from uploading a few hundred files to I get a due diligence report that's completely automated. You can select your criteria which matter to you. So if you're a Core Plus investor, you might have different criteria than a value add investor. Just give that to the model, and it will learn about your context, and we can prepare the investment presentation for you according to your style, according to your criteria. So this is how we are bringing what we have learned in IT to the real estate industry, and to end similar to Henrik, like the the first part, this intelligent structuring, which we have optimized a lot, is the core discipline here, because without the high quality data, with all those references between data points, the subsequent steps, the due diligence, the validation, all of those will fail, and whatever you build on top is just not as good as if you would do it correctly in the first way. And there, AI is a big helper, because it does it more carefully than we do it. It has a lot of time to think, which we don't want to do. And it will do it in the most granular way in the first place. Even so, we might not need all of the data, but then having it is better than later on having to search for it.
Thank you, Nino. This is really fascinating. I was just thinking about redoing our website, so you gave me an idea how to do it. Yeah, that being said, what I really want to double click on, and this is a good segue to you, Louise. Nino, you said that with 2 people, engineers, now they are able kind of to do the work of 5 people. And I also think this is a little bit true for your area, Louise, because you're helping property managers basically scale themselves to deliver an improved tenant experience. Would you mind sharing more about that?
Yeah, absolutely. Great. Okay, yep, just to reintroduce myself. So I'm Louise, the program manager at Ask Porter. So today I'm here to talk with you about something that's happening now in the world of FM real estate. So how Europe's leading FM provider, one of them at VISAG, moved from a state of reactive firefighting to a more streamlined and data-driven operation using AI co-worker named Ellie in a very high stakes and commercial FM environment. So what we're going to do today, just over the next sort of 10 minutes or so, is focus on the solution itself. We'll also touch on how they transitioned from their legacy tools to a more streamlined workflow, the results, and then a couple of the hurdles that we encountered along the way. So before we dive in, just a quick setting of the stage. So Ask Porter, as Monica introduced at the beginning, is an AI platform. We were founded 10 years ago, and we have built a suite of agents that automate the operational noise around FM. So delivering cost-effective operations with the aim of freeing your workforces to focus on higher value tasks. You can see the stats of our kind of user base there. And VISAG, our partner, so they manage properties at scale in Germany and across Europe, so Luxembourg, Poland, and a few others. So they've got around 250 sites, and they serve some of the most complex sectors. So they have a lot of office buildings, but they also work in airports, data centers, and hospitals. In 2021, they made a strategic move to introduce Ask Porter's AI to transform their legacy service offering to a smarter and faster digital experience for their global clients. So we'll look at what that was in just a moment. So first of all, we'll look at the challenges that they were facing. So before implementing Ask Porter, they faced the really common issues that we see in our FM space. So reactive firefighting, heavy manual reliance, and very high friction old tools that tenants just didn't want to use, and they just simply ignored. So the systems that they had, the processes relied on phone calls, emails. I'm not telling you anything new, but a lot of these reports lack detail and required follow-up manual triage from a human. So for VISAG, what this meant is that their technical staff were spent chasing more time, just trying to figure out what work needed to be done and chasing the data rather than actually getting out, maintaining the buildings, resulting in avoidable delays and impacting on their SLAs. So VISAG had a big ambition to kind of lead the charge on AI, lead the FM market, but they were being held back by their old tools that couldn't provide the solution they needed to continue to roll out internationally at scale. So they needed a bridge, the gap between their current operations and their digital future, which is where we came in. So let me introduce you to a project that we call the TaskRaiser for VISAG specifically. This is called Ellie. You can see a little profile picture of her there in the middle. So she was built on our agentic AI system. So to perform complex reasoning, diagnose issues, and then execute the tasks that were raised autonomously. So what she does is capture issues, whether that's via scanning a QR code on site, interacting with IoT devices, receiving emails or web chat conversations. She uses natural language processing and understanding, and also image analysis to understand technical intent within a rich context. So I've got a little example along the side there. So if the tenant says something vague, there's a puddle under the cupboard, so there's water under the cupboard. What AskPorter's AI will do is what a lot of AI models will do, which is identify the intent, the end of the maintenance issue, the entity being the thing, so the leak itself, and also the context of the location. Mapping it to the correct asset, including passing any kind of visual data that's been uploaded as part of that information capture. So being able to determine urgency based on the data contained within images as well. If the interaction method is conversation, so the user will follow a dynamic logic path, which is a step beyond some of the older kind of AI agents. Now we're in this new generative and LLM world. The paths can be a lot more flexible in terms of how the end users are interacting with systems. So triaging and diagnosing FM requests are how we built our guardrails and how we the focus that we have for this project. So by the end of a conversation, Ellie has ensured that the task that will be raised at the end of a conversation has all the necessary context, rich data to create a work order that's ready for action. So turning kind of a vague concern to a very specific issue that's then ready to be actioned. So from puddle under the cupboard to minor leak from pipe in kitchen unit 5. So now the human engineer can arrive on site with the right tools and the right parts because the data was captured correctly up front. So yeah, let's talk about the implementation. So in the first phase, we didn't try to solve every edge case. So we focused on the top 20% of issues, which is actually around 80% of the total manual workload. So the low value, high volume tasks. So this ensured that when the AI agent was implemented, it was useful from day one without overwhelming the technical teams. So we started off with a 6-month pilot in Frankfurt, just did a small selection of VISAG's offices. And then based on that success, we onboarded every new client to the VISAG portfolio with Ellie since 2022. And so the goal is by the end of this year that the entire portfolio, including some of the legacy stock, will be AI driven. So making use of the further efficiency gains. Another secret to our success is our ability to have complex integrations across different divisions within VISAG. So the integration strategy was implemented from the beginning of this process to break down the siloed data, which is so common in our sector. So we worked with the VISAG maintenance division, who work very closely on a CAFM infrastructure system called Remus. So we built a kind of bi-directional ticket synchronization with that system. But for cleaning tasks, they didn't have that CAFM system. So what we did is move the entire workflow into AskPorter to take full advantage of the native automation that we've got running in the background. So the result was a unified data set across 2 very different service lines.
Thank you, Louise.
Mhm.
Okay. No, go on. Go on.
No worries.
Just I'm the little timekeeper here. We're a little
No
bit over
problem.
time.
Yeah, so just the verdict then. So we ended up managing 12K properties at 48K tasks with 100% automated handling. We were able to deflect 13% of all of the tasks, so providing safe automated troubleshooting, and most importantly, we achieved a 97% diagnostic accuracy, meaning we are able to identify the problem correctly almost every single time. So yeah, if we're out of time, I will stop sharing.
Thank you, Louise. I think, Louise, your solution really solves a very, very painful situation on the market. So keeping tenants happy. And I would particularly like to dive more on your implementation process. So maybe we do a follow-up session, because I know for a fact, like, people struggle with implementation and the change management and bringing everybody on board.
It's certainly a complex but very rewarding task to implement an AI workflow.
Correct. And yes, so I would like to thank our esteemed guests today. I hope this was a revealing experience for you. So we saw how AI is actually applied from the moment you decide to buy or to sell a building, how to set it up, let's say, through the digital twin, and from a machinery, sensor, IoT, to optimize the building costs, but also the experience, and finally closing with making the tenants happy, which keep the rent roll coming in. So I would like to thank you all again. We will send this presentation and the guest contacts. If you should get in touch, try a pilot of your own. I'm sure everybody will be super grateful. So with that being said, I wish you a very good day ahead, and see you soon for more AI insights.
Yeah, thank you all. Very interesting.
Thank you so much.
Thank you all. Bye-bye.
Bye.
Bye.